All right. Well, so last night was, you got that extension on the homework, but yeah. All right. So you had, the first night you had the 15 through whatever, and that was just the extreme value theorem that was finding the maxes and mins, and then the second night was 1 through 10. So any questions that you have on any of those, holla.
Hold on, wait, which time was 15?
So the first one was 15 through 28 or something. And that's where we were just doing the sign analysis.
Yeah. Can we do like a couple of those?
Give me one to do.
40.
40.
What page is 40 on?
I didn't get the 40.
I wrote it down.
Can we do one of the earlier ones first?
Yeah, let's start at the beginning.
Do like 22.
Yeah, 40 you just sketch it.
Oh, yeah, but, okay.
Which page is 40 on?
Here's the point of this question. The point of this question is that you understand what it means when the derivative is doing certain things. Where'd it go? Here it is. All right. So the given here is that f of 2 is 3. So this has the point 1, 2, 1, 2, 3 on it. We know that. Now, if the anything smaller than 2, so I'm going to the left side, the function is doing what? If the derivative is positive, what is the function doing? Increasing. It's going up, right? So whatever else it's doing, it's going up. Because this tells me that the derivative is 0 here, that tells me that this point is a what? A maximum or a minimum, right? It's a critical point. And then bigger than 2, it's decreasing, so I'm thinking it's some type of parabola that has a maximum at that point. That's all you have to do there.
How'd you know that it seemed like it was so much more?
I don't know.
How'd you know that bigger than 2?
Okay, so this is for x is greater. So when x is bigger than 2, the derivative is negative. Anytime the derivative is negative, that tells me that f of x is decreasing.
So basically it's because like change.
Basically, say that again. The sign of the derivative, right. At the maximum, the sign of the derivative changes. Because it said that the derivative was 0 at 2. Just doing the same graph in a different color. It says that the derivative is less than 0 when x is less than 2. And it says that the derivative is great. It's basically the opposite. Derivative is greater than 0 when x is greater than 2. These are requirements for all of these, A through D. So, right, this is still a max or min, but this time it's doing this. Because this means it's going down, it's decreasing, and this means it's increasing.
Is that all you do? Just draw a graph? So we would have to draw separate. On a test, we would have to draw separate graphs.
No, I wouldn't give you this many on a test, no. You'd have one. Part C says that the derivative is less than 0 when x does not equal 2. What does that mean?
Well, that means that there's a jump or a oh, you know what it is? You know what it is? I bet you it's a hole right there. Is there a hole right there?
This means the function's always decreasing, right? Because when it's not 2, so it can't be. So you're right. I think it's a hole there. I think we would have to interpret that being a hole. So if it's always decreasing, it looks kind of like a cubic that doesn't have any defined maxes or mins. And I would say undefined there. I would have a hole there.
Wait, is this part C or is this the whole?
This part C.
Wait, so these are all different parts of the graph?
Mm-hmm.
It says the derivative is less than 0. That means it's
right.
So that means it's
Decreasing. So always decreasing. Yeah. No, you could. I'm just making things more difficult. You could. Oh, I didn't know it was open, to be honest. And then D would just be the opposite because it's positive. Let's move on to another question. Give me another
Can you
question.
please do 22?
4 from page 270.
I want one of the earlier ones.
Which one?
4 from 270. That's the other homework. Or 5.
All right, we'll start with 22, then we'll move forward. All right, guys. It says use analytic methods to find the local extrema, the intervals on which the function is increasing, and the intervals on which it's decreasing.
I just want to be like, why do you want
Okay, so I have to find where the derivative is 0, because where the derivative is 0 is where
so
the
you get the derivative?
changes are potentially happening. But they could be what kind of point? It might not be a change in direction, but it could be undefined, or it could be it starts with an S. I'm gonna pull question answers. A stationary point. That's right. Okay.
I don't understand what those are.
Stationary points is where it rests, so it doesn't actually.
Well, the points are never moving.
Okay, but it doesn't change direction. It doesn't. When the derivative is 0, it's a max or a min most of the time, but it could just be a point where it doesn't change direction, but it just rests for a minute. Remember when we did particle motion? We had to check the velocity to see if the sign actually changed, and we said if the sign didn't change, that meant my little bug just stopped for a minute.
You mean something like here?
How do you know?
Right.
How do you know?
Well, we have to check it. That's what we're going to do. We're going to check to see if the sign changes or not. All right, so derivative here. Whoa, Stacy. 4x cubed minus 20x. Set that equal to 0. I'm going to take out a 4x. Leaves me with x squared minus 5. Okay, so I have 3 zeros here. We'll set that to 0. We'll take the GCF out first. X doesn't equal 5.
Wait, how did you get x squared minus?
I took a 4x out from both of those terms. Who did? They who? Yeah, who is they? The what? I was going to say, if your solutions did anything other than this to start with, then they are wrong.
No, they
How did they complete the square?
they did 4x times x plus 35 times x minus 35.
But they still got the same critical points there, right? All right. Remember, I am going to check the sign of the derivative to tell what the function itself is doing, right, guys?
Yes, ma'am.
All right. I'm going to go here. Maybe, guys, maybe -3, but I'm going to pick a test point, right? And I'm plugging into the derivative. And I can either plug in here or I can plug in here. It doesn't matter, okay? I would plug in here. It'll be a little easier to see the sign. Because if I plug in a negative number, this is going to be negative. If I plug in 3, -3, that would be 9 minus 5, which would be a positive. A negative times a positive is a negative. That's exactly right. Don't make more work on yourself than you have to.
How'd you move it? -3 as well.
Yeah, well, the square root of 4 is 2. It's a little more. So I just went with that condition. How about -1 for the next interval? If I plug -1 in, I get negative times a negative, which is going to give me a positive. Now remember, this means this is decreasing here, increasing here. Now go +1. This parentheses is still going to be negative, so it's going to be negative.
That's a max right
It's going to be
there.
the same thing for them.
And then this one, what's it going to be doing? You don't have to show where you plug that in. You don't have to do any of that, because what I have to do now is interpret my answer. Okay. So it asked me local extrema. So I don't even have to test these points because it didn't ask me to test these. It didn't say absolute. I only have to test the points when it's asking for those absolutes, right? Well, then I would have to check this and this.
Those points.
Right, to see which one's lower on the graph. But because the ends of this go different directions, you're not going to have an absolute, right? This is coming down, having a minimum, then it's coming up and having a maximum. It's coming down and having an, oh, yes it will. It will have an absolute. You'd have to plug it in and check. It wouldn't have an absolute max, but it would have. But this just asks us for locals. So locals are good because locals, all I have to do is look for sign changes. So here, I have a local min at x equals negative square root of 5 and x equals square root of 5. And make sure you say y. Yep, that's right. Because the derivative changes from negative to positive here.
When you write this out, B and C.
Yeah.
Just use your words. So the intervals on which the function is negative 5 to negative square root of 5 is 0 and square root of 5.
Increasing would be negative square root of 5 to 0 and square root of 5 to infinity. That's correct. All right, number 4. Number 4 didn't work.
Wait, were they use brackets or
So what?
what? Yeah, the slope is brackets.
It's brackets on the function. It's parenthesis on the derivative.
No, the derivative.
What did you say? I'm pretty sure it works. They use brackets.
So I should do. Yeah, you're right.
It should be brackets.
Yeah. We're talking about the function, not the derivative. X to the negative 1/3 equals 2/3. This is the one Van and I worked on like for about 3 hours yesterday. No, I'm just kidding. It's okay. It was just because we were texting. So what do you need to multiply? You can always raise to the reciprocal. Make them cancel out. So here, this is going to be x equals. The negative is going to make the fraction flip. So I'm going to have 2/3 to the positive 3, which is 2 cubed over 3 cubed, which is 8 over. Okay, you're welcome.
Yeah, I had to write all that down.
So number 4, you should go back and read the directions for the question on number 4. I'm sorry, man. I didn't know why you were asking. I thought you were working on SAT stuff at some point, and that's why you were asking me certain questions. But I didn't realize you had. But okay, so this one said state whether or not the function satisfies the hypothesis of the mean value theorem on the given interval. So this function is. What are the, what did it say, hypotheses of the mean value theorem? There are 2. It has to be what? Continuous and differentiable on its entire interval.
Oh man, the graph of an absolute value function is not different.
Why is it not differentiable? Because of the corner. You're exactly right. So you didn't even have to go any further with this. You could say, no, it does not satisfy the mean value. I am really sorry. I didn't know what you just said. Can you take the derivative of an absolute value? And I said, sure. Here's how you do it. I didn't realize. So I'm sorry.
Wait, so how do you
It's not hard. It's not a bad one. It's just not one that we have to do.
I don't even know what you would do.
But it's not differentiable at the corner itself. So since we're talking about on 0 to 4, and this one, if you think about an absolute value, looks like this, but this is slid to the right 1, so it's really right here. If I'm talking about from 0 to 4, that corner's still caught in that. Now, if this had said from like -4 to 0, I could, that portion is differentiable. But because that vertex is in that interval, does that make sense? That's really what they were testing you there. Do you understand that an absolute value is not differentiable at its vertex?
What does it mean? Honestly, I've asked this before, but what does it mean?
The
slopes have to be
The slope from the left is not the same as the slope from the right as you come in. So the left-hand derivative and the right-hand derivative are different. And if you think about it, if you're coming in like this, right, the tan line here is like this, the tan line here is like this, so they're different. If you think about like a parabola, though, as you come in here, you're approaching the same value as you come in. It's not just a straight point there that it.
What do you even say?
So part A says state whether or not the function satisfies. No, it does not satisfy the hypotheses because it's not differentiable at its vertex. And part B says if it does, well, it doesn't. So I don't have to do part B. What else?
Can you do number 7? I would say you can. Oh yeah, 7 is a good one. 7 is good.
Yeah, 7 can't do either.
Why not?
Okay, but just because it's a piecewise doesn't mean you can't do it. But what do you have to check for? That's not, All right, I first have to check the hypotheses, which is where this one is going to fail. So remember, I have to think about continuity and differentiability. So the first thing I would check if I was doing this is the point where they overlap. It better be the same, right? Because it's got to be continuous. So does the cosine of pi over 2 equal the sine of pi over 2? No. Pi over 2, where's pi over 2? Up at the top. One's 0 and one's 1. So no, that does not equal. So it's not continuous. And if it's not continuous, I don't meet the.
That's a red flag.
That's a red flag for sure. Nope, 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 nope. 3 years is not. Oh my God. Anything else? It's not as hard as what you think. We did 9 with the x plus 1 over x. I do remember that one. All right, so my interval's from 1 to 3. Okay, so I want, remember, MVT has to do with endpoints. So somewhere, you understand MVT, yes? Do you need me to give you a little recap real quick?
Yeah. I mean, I did all the homework and stuff.
Between any two values on a function, okay, if you were to connect these 2 points and find the slope there, this is what we call a secant line.
Yeah, I remember that.
The slope of this secant line, there is at least one point between those 2 points where the tangent line has the same slope.
Oh, so they're parallel.
So they're parallel. That's exactly. So somewhere, and it doesn't have to be a max or a min. That one looks like a max or a min, but it's not really. It doesn't have. It just says that if you connect any 2 points on there, if it was this point and this point, or if it was this point and any 2 points, then in between those points somewhere, there exists at least one tan line that has that same slope.
Wait, so it has to, the secant line has to represent the endpoint?
Well, it can go between any 2 points you have on. I mean, it doesn't matter.
How does that work? How do you write it?
Let's say I chose, let's say this point and this point. And I connect them and I find the slope. That's a secant line, right? Somewhere in between these 2 points in this little section right here, there's a parallel tan line. That's all it's saying. It's cool though, right? I mean, I could put them really close together. Okay. So here, the first thing it asked me to do is it asked me to write an equation for the secant line. Here is A, and here is B. Okay. So to find this, I'm going to need to find f of A and f of B.
A equals A f of x. B equals B f of B.
Because those are the endpoints of the lines. So it's saying whatever I have this point A, and then I have this point B. The coordinates of this point are A, f of A, because I plug in A to find, right? And then, right, exactly. So I'm finding the two endpoints of the secant line is essentially what I'm doing. It's just a bit wordy. So this would be the square root of 1 minus 1, which would be 0. So I have the point 1, 0. And here I have the square root of 3 minus 1, which would be the square root of 2. So I have 3 square root of 2. So now all I'm doing is I'm writing the equation of the line through those 2 points. So find the slope. Yeah, but remember.
So 3 minus 1 on the bottom and then square.
Oh, do you recognize it? I'm going to choose 1, 0 to write my equation. Slope times x minus 1, and I'm probably just going to leave it, right? There's the equation of the secant line. That is way back basic algebra 1, right, where I just write the equation of the line given 2 points. It's just wordier now. And this is when you have the mean value theorem. F of B minus F of A over B minus A. There's that part. It's just A rock. That's all that is. And that's what I did.
How do you know which
X
and Y points?
Oh, so you just said slope.
I just did slope, right? Yeah.
Okay. How do you know which X and Y
Wait,
points?
what about?
Okay, so it gave me the x's. You're talking about which one you start with?
Well, when you're writing the equation for the
You can use either one of these two.
does not matter.
It does not matter.
The equation of the tangent line is parallel.
So, right. So now it says a tangent line is parallel. So that means if it's parallel to the secant, that means I'm looking for a tan line with the same slope. So the tan slope is going to be square root of 2 over 2, right? And to find the tangent, I need to find the derivative. So what I'm essentially looking for is where does the derivative equal that? Okay. You're still doing the same thing we've been doing. That's what I really want y'all to see. It's nothing new. It's just different wording now. The only new thing is understanding that. Yeah.
Yeah, that's why I kept texting this. We should do this. I could not do this.
All right. So remember, f of x is, or y is, since I used y there, y is the square root of x minus 1. So if I do the derivative, that's right, 1/2 x minus 1 to the negative 1/2, and then chain rule here would just be 1, so I don't have to worry about that. So where is this? And I'm going to write this way because I think it'll help you see it a little better.
Wait, can we raise so can we do the top to the 1?
Can we do what?
You are square root 2 over 2.
Mm-hmm.
Wouldn't it be easier to do 1/2?
If you want to. What I would probably do at this point with all these radicals is I would probably just come here right now and do this. Sure. Just make sure it goes to everything. It's going to go top and bottom. 2 over 4. 1 squared is 1. And now I got to square both of these. So it's going to be 4 times, and then the squared and the square root cancel out.
Can you tell me how you wrote the second part with the 1?
You're talking about how did I get here? Because this exponent is negative, it moved to the bottom, and a 1/2 exponent is a square root.
Or goes to the top.
And now you could cross multiply. No, we'll work. What's confusing you? Yeah.
It's just like
It's the algebra. It's the algebra. It's always the algebra.
put squared in it.
So what you did was you flipped.
Okay, so
How did you got the one at the top?
So you flipped it. You flipped it.
Van, see if this makes it easier for you. If I'm here and I want to know where does the square root of 2 over 2 equal 1/2 times x minus 1 to the negative 1/2. Get rid of that by multiplying by the reciprocal. What's the reciprocal? 2. This actually will be a little bit easier way to solve it. If I multiply by 2 and I multiply by 2, this is gone. This actually cancels also. So I end up with the square root of 2 equals x minus 1 to the negative 1/2. Now, just like when you had that negative 1/3, what can I raise both sides to? Negative 2. The negative just flips it, so really this is 1 over the square root of 2 squared. Right? That's 1/2, and just add 1. So if I'm back over here, I divide by 4, I got x minus 1 equals 1/2. There are 2 different ways to solve it. Remember, algebra is great that way. You can do it. But that is not what it asked me for. The only thing I found is the x value where the parallel tan line is. So you plug in. So I need to know when x is 3 over 2. So what do I want? The actual function. You're exactly right. The actual function. Do what? We did find the derivative, but the only thing we found the derivative for is to find where on the function the tan line has that value.
Okay.
Remember, the derivative is the slope of the tan line, right? So we found the slope of the tan line. So now we need to find what is that point. So whatever this graph is, when x is 3 over 2, what's the other half of that point? Because this is the point where the function and the derivative share that value. All right, so f of 3 over 2 to find the y value. So this is the square root of 3 over 2 minus 1. What you write is the square root of 1/2 square root of 2 over 2. Right? Square root of 1 over the square root of 2 is 1 over square root of 2. Square root of 2, square root of 2, square root of 2 over 2. So I've got a slope and I've got a point. So 3 over 2, square root of 2 over 2. That's also my slope, isn't it? Is that right? That's the slope and the y? Y minus root 2 over 2 equals the slope. They probably simplified the answer a little more, solved it for y, but that's okay. Antiderivatives is exactly what it sounds like. We're going to ease in. This is not bad. This is, and we're just going to do it for ones that we know right now. Familiar things that it's absolutely. We're just going to think about it, kind of like whenever you first learned to solve an equation and it was like, what would you have to plug in here to make this work? You didn't actually learn how to solve it. You just learned what it meant to be a solution. We're kind of going that route with this for right now. But so antiderivatives are the opposite of derivatives. That's all we're looking for.
So the antiderivative of 2 would be 2x.
Yes, plus a constant.
So the antiderivative of 2x.
Okay, so Van says that the antiderivative, and by the way, antiderivatives, I am going to note as capital F of x if the derivative is f of x, then I'm going to call the antiderivative big F of x. I'm just working backwards. So Van says that if f of x is 2x, then the antiderivative should be, what did you say?
I started with 2 and then said 2x.
Oh, okay. Okay. Does anybody disagree?
Please don't ever do that. Please do not ever.
What's the derivative of x squared plus 1?
The regular derivative? 2x cubed plus x. Oh, wait,
Hmm.
I thought you meant.
But you told me it had to be x squared.
But how do we know if it's like
It's the same thing.
We don't, but that's a good point. When we do antiderivatives, we have to follow it with this plus c value because the derivative of a constant is 0. So there could be any constant tagged onto the end of this antiderivative. So I have to take that into account. Okay? And that's kind of the point I was getting at here. So I wanted you to see that it doesn't, yes, you're right, x squared's derivative is 2x, but so is x squared plus 1, x squared minus 5, x squared plus 1,000. The derivative is still 2x. Exactly. Plus Aaliyah. Was that what you said? All right. So we're going to think through that power rule and we're going to reverse it. So let's think through for just a minute. When we do the power rule, what do I do?
Take the top exponent down, multiply, and subtract.
Okay, so I've got x to the n. So whenever I find the derivative, I bring the n around, multiply. So I need to reverse that because now I'm going, instead of going this way, I'm going to go this way for the antiderivative, right? Okay, so what are you doing? How do I reverse this to get back to n? All right, so let's see, antiderivative. I'm going to add 1 to the exponent because when I take the derivative, I subtract 1, right? I multiplied around front, so to undo that, what do? Divide by what? Do I divide by the new exponent or the old exponent? The new exponent, the one where I added 1 to it, right? And then I'm going to add plus c on it. Let's do some generics with plus c, and then I'll show you how to get rid of the plus c in just a minute. Not yet. Find if, y'all got all that? You need me to wait a second? I'll wait a second. Yeah, I'm fixing to do several examples of it.
Okay, so what we just did.
Yeah. Did she say stop sneezing?
Stop shrinking.
I need to have a party.
Wait, her birthday's tomorrow?
Is y'all's blood drive tomorrow? Oh, no. Are y'all missing this class?
No, I'm missing third block.
Oh,
I almost had
thanks,
missed
y'all.
that, but I got in this third block too. Love you. No one asked you. You get hours.
Find the antiderivative.
5x.
it's 5x plus
5x plus
Let's go to 5x.
Yeah. 5x plus c. I don't think you might should drink that.
I think it's tasty. I need something to get rid
Okay, how about this one? What is f of x?
x squared plus
All right, so do y'all see what we're doing? You add 1, so this is going to 1, right? We add 1 to this, and then we divide, this is 2, so we divide this by the 2. We're the backwards of everything we were doing, and then we do the plus c. You can probably think this through in your head, but it gets a little bit It gets a little bit harder whenever you get like fractional exponents and stuff.
So you can take what you added and divide it by your whole
Right.
number. Sammy Vernon Aaliyah Tucker the third.
Let's do one a little bit harder. Find the derivative. Find the first derivative if that's the second derivative.
Oh, wait. Oh, we're going. 3x plus 4.
Yeah, it would be 3x to the third.
3x cubed.
Oh, we're doing the antiderivative.
Antiderivative.
Well,
I did it in my head.
that's not the proper notation for
What's the
antiderivative.
logic?
Well, if you start at f of x, it ends up at big f of x. That's the backwards of it. But if I start at second derivative, then the antiderivative would be the first derivative. Yeah.
What is the logical way to do that? I did that like in my head thinking about it.
You can do that in your head.
It's 3x cubed plus 2x squared.
Is there like a certain number you know?
Minus 6x.
and all that?
You know that you kind of shoot this stuff in the left.
Did I? Oh, did
It's
I?
like, yeah, which, like you had.
Oh,
if
but
this is true, what is the second derivative? Yeah, and it was barely wrong because the only thing that changed was.
well, but you could have taken the second derivative given and found the other derivative, or you could have gone, backwards.
You know, this thing is making me bounce off.
Like if this one was true.
Okay, don't drink anymore because you're making me nervous.
Who wants it?
Like down the.
No, you're the.
Like you said, given the second.
We did. And then we're gonna find out how to get rid of the c in just a second. This is.
Screw the C.
Oh, you were doing it again? Well, if you did it again, since you've got that constant, you'd have cx, right? And then you'd have another c there. But yeah, we won't go. We won't. You want me to do it? Plus 1 divided 3/4 x to the 4th. They're doing it again. They want to do it again. They're anti-deriving the antiderivative. But this we should probably use a different variable because really they might not be the same.
D as in.
Dog. Yes, no, maybe so. Y'all didn't have to do that last step. Ren just. If you did it again, which we're not, it would be the next one would be big F. No, you don't, Ren. You don't have to go any further. Oh my gosh. All right, remember, plus 1, and then you divide. Plus 1, divide.
Crazy, right? It would be I. Yeah, that should be imaginary F.
Sorry.
Can we just do the next one?
There's this take this top.
We don't have, y'all, no, this was not part, Ren just asked me to do it. You won't have to do more than one. No. No, Ren just said do it, Miss McGee, do it. Okay.
I got hurt at practice. So you're saying you actually can't find the antiderivative of the antiderivative?
Yo, you can.
That's what it is. Well, I was actually.
Okay, the antiderivative of the.
What's f of x?
No.
Think carefully before you answer this.
It would be. No, negative cosine.
Carefully.
Negative cosine.
Yeah. You know there's a trick if I say think carefully. Negative cosine plus c. Why is it negative cosine?
Because the derivative of cosine is negative sine.
The derivative of cosine. What's that mean? Oh.
Wait, what if
All right, here's a challenge. Don't blurt this one out if you get it.
Not a C?
You have to put a C if you're doing antiderivative.
There might not be a C.
Wait, can you tell me one more time why it's negative?
Wait, I know it, I know it.
Don't say it. Don't say it. Don't say it. Don't say it.
You literally don't even know.
I need it, do not say it. Wait.
Don't say it. Write it.
Oh, Leah, I'm so impressed. Yeah, but she was so excited because she knew it. Yeah. Oh, Leah. Oh my gosh. The ln of what? Natural log of just x? X minus 1 plus.
Yeah.
That was pretty easy.
Was it? Did y'all think that was easy?
Yeah,
So every antiderivative you're doing are going to be ones you're familiar with like that. Now, this is what we call a generic. Or what I call a generic. I don't know that that's technical terms. Generic because we got that C in there. But you're going to encounter some.
What if you don't have a C? Like, what if there's,
You have to add.
no, but there might not have been a number there.
But they can only just assume that there wasn't.
If I'm given a point that it goes through, I can sub it in and find the C. So this will be the antiderivative.
That's alliteration.
So, oh my gosh, y'all are off the chain today. Okay, the antiderivative. So the generic one, I could plug anything I want for C and it still holds true. For the antiderivative, there is only one answer. It is the answer. It is the antiderivative. But to find it, I have to have a point. So I'll be given, it'll say, for example, find the antiderivative that goes through that point. So find big F of X.
I don't know. You might be left door for government. Are you just supposed to think about it?
No, you're supposed to do it.
No, I mean like in order to, there's no like actual.
Right, there's no formula for this. The formula I gave you is for polynomials. When we're doing like power rule kind of thing.
Okay, so we gave you a point. So
Yeah.
Oh, I'll tell you what it is. So it's gotta be
What is the antiderivative of negative cosine x?
negative sign X.
Plus C. I'm still going to keep the C in right now,
So you
okay?
put pi for X.
And now I'm going to use this point so that I can, exactly, I'm going to try to find the C. So, solve it for C. Solve it for C. What is the sign of pi? It's 0. So negative 0 is just, so I've got 3. So, y'all.
wait. How do we know to plug that 3 in?
That is, I solved it for C, so I put that back in my general and my generic antiderivative.
No, but like sooner than that, you got the.
They gave me this point. So this is my X and this is my Y. I plug this in for X and I plug that in for Y and I solve it for C. Let's do just one slightly harder. I will tell you it will benefit you, like number 35 is negative 1 over x squared, and you're finding the antiderivative. Make that negative x to the negative 2 so that you can add and divide appropriately.
So
Say it again. So 35, let's do it. We'll just do it. It's not the one I was going to do, but it's okay. 35 says that the derivative is negative 1 over x squared when x is greater than 0. Find the antiderivative that goes through the point 2.
Okay.
No, I didn't say anything. She told us what it was, negative x. That's not.
Stop talking.
I'm just saying, like.
I know this. But half of them.
Well, why don't we like not solve that by wait? Can you spell it quick? We all just be quiet.
I know.
All right.
So you're gonna add 1.
So, right.
So that'll be negative 1.
Negative 1. My brain doesn't think that. Negative 1 divided by negative 1.
And you can always go back and check by finding the derivative and seeing if you come back to that same value. So that would be your gut instinct, but because it's x squared in the bottom and not just x. If it was 1 over x, it would be natural log.
X to the negative 1 plus 2.
So it's going to be x to the negative 1 plus c.
Wait, so why do you x to the negative 1? How'd you get that x to the negative 1 from?
Because I add 1 to the exponent, and then I divide the number in front by that value. But I need to find out what c is, so I'm going to plug
So you
in.
moved here. So for the first part, you moved the bottom thing from to the top and made the exponent negative.
Yes.
And then never mind.
Because there was a negative 1 in front, so then
Divided by negative.
negative 1. Right, negative 1 divided by
So
negative
you
1.
could move the whole thing to the top and make the exponent.
Yes, yeah, or make it negative.
Change the sign.
Mhm. That has stumped you for quite a while,
No,
man.
but like I thought I asked you that yesterday, and then you were like, no.
Yeah, no, you can. Anytime you move it, you change the sign. Move it, change the sign. All right, so 1 equals x to, or no, 2 to the negative 1 plus c. 2 to the negative 1 is 1/2. Subtract 1/2.
Awesome.
So the antiderivative here is x to the negative 1 plus 1/2. Have y'all had enough for one day?